Hi guys, my name is Nelson and this is Nelly Mark's concept. This is where mathematics is made very simple. In case you have not subscribed to this beautiful channel, please kindly subscribe, like our videos, drop comment and share our videos. Thank you so much. We have a topic, permutations and combinations, to discuss with you today, but our focus is going to be on permutations. All right, we are going to focus on permutations. Let's look at the outline. We are going to define permutation, then we solve some problems on permutations. Let me give a disclaimer here. Most of the questions we'll be solving today are jam past questions or past jam questions. So if you are preparing for jam or you are offering further maths in high school, this lesson is very important for you. And of course, the lesson is going to be beneficial to everyone, to every lover of mathematics, because in this lesson, we are going to be applying common sense. You know, there's a saying that says common sense is not common. So in this lesson, we are going to employ a lot of reasoning, and it will really help you. It will help a lot. So, all right, let's look at the definition of permutation. Now, permutation is an ordered arrangement of some or all of the elements in a given set. Emphasis on ordered arrangement. Okay, permutation is arrangement, okay, but it is an ordered arrangement. Okay, so don't forget that. Take note of this. Okay, it is an ordered arrangement. It's a kind of arrangement in which the order matters. So let's take an example. Arrangement of letters of a word. Different arrangement of letters of a word is permutation. Okay, if you are given a particular word, there are different ways the letters of the word can be arranged. That is permutation. All right, so let's take the word ray for instance. The word ray is spelled R-A-Y, and R-A-Y is the default arrangement of the word ray. So there are also other ways the word can be arranged. This is permutation. We have R-A-Y already, then R-Y-A, all right? Then the word can as well be arranged as A-R-Y, okay? Then we also have A-Y-R. We can also have Y-A-R. And finally, we can have Y-R-A. So if you look at this, you see that there are 6 possible arrangements, okay? There are 6 possible permutations of the word ray, okay? So every word has its possible number of permutations. Take Nelson, for instance. Nelson is spelled N-E-L-S-O-N. So Nelson has its own possible number of permutations. Then your name, you my viewer, your name also has its own possible number of permutations. But then how would we know the number of permutations that exist in every word without having to write out the permutations? How do we know? I'm going to give you a formula for that. Okay, so the formula is N factorial. N factorial. Okay, so there are n factorial ways of arranging n items. What this means is that the permutation of n items is what? N factorial. Okay, so let's go back to this word ray. All right, so ray has how many letters? One, two, three. So ray has three letters. It means there are three factorial arrangement for the word ray. Okay, or there are three factorial ways of arranging the word ray. At this point, you might be asking, what is factorial? All right, I'm going to explain the concept factorial in the next slide. Let's move on. Okay, factorial. For any counting number n, the product of all the positive integers less than or equal to n is called n factorial and denoted by n, then followed by this exclamation mark. All right. I'm going to give you a mathematical formula for factorial so that it will aid your understanding. Okay. So the mathematical formula for factorial is n factorial is equal to n times n minus 1 in bracket times n minus 2 in bracket. You can as well add n minus 3 in bracket. That continues until the number is reduced to 3, then times 2, then times 1. Okay, it's very, very simple. Let's take a real example. Let's take an instance with a real number. If you have 3, okay, 3 factorial means 3 times 2 times 1, and that gives us 6. All right, so let's take another number. If we are taking the factorial of 5, it is 5 times 4 times 3 times 2 times 1, which is what? 120. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is what? 120. Okay, so 5 factorial is what? 120. Okay, then if you are given 10 factorial, 10 factorial is going to be 10 times 9 times 8. Okay, you can complete it. Yes, times 7, on and on, down to times 3, times 2, then times 1. It is that simple. That is what a factorial is. Okay, you have now seen why we got 6 arrangement for ray, for the word ray, in the previous slide. Okay, ray is a 3-letter word. All right, so the number of arrangement of the word ray, or the number of permutations of the word ray, is 3 factorial. We got 3 because there are 3 letters that make up the word ray. R-A-Y. Okay, and 3 factorial gave us and 3 factorial always returns 6. Okay, so if you are given a word and the word has 3 letters, it means there are 6 permutations of the letters of the word. Okay, so my name Nelson has 6 letters. It means there are 6 factorial ways of arranging the letters of the word Nelson. You can do yours. It's an assignment for you. All right, let's move on. Okay, R in bracket factorial is used when R element of set n is being required. Okay, if you are arranging some of the items of a set, this formula is always useful. Okay, that is, if you are arranging 3 items out of 5 items, you are arranging 10 items out of 20 items. This formula is important. Where the number of items you are arranging is called R, and the total item is what? N. And this is the formula. At this point, you already know what a factorial is. So we're going to apply this formula in solving some JAM questions, and you are going to enjoy it. I promise you. Let's move on. Example 1. Find the number of ways that the letters of the word excellence can be arranged. I like this question. We have a word here, excellence. Okay? Now let's look at the solution. Excellence is a 10-letter word. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's a 10-letter word, and it is obvious letter E appears 4 times. All right. Then letter C also appears 2 times. Finally, letter L appears 2 times. Okay. So what do we do with these letters that appear more than once? So we are going to divide 10 factorial by the product of the factorial of this number of times the letters appeared. I think that is clear. Okay. So our answer would have been 10 factorial. You know, if you are given the word Nelson to arrange, it is 6 factorial because no letter appears more than once. But in the word excellence, we can see that letters E, C, L appears more than once. So the factorial of the number of times they appear are going to serve as a factor of 10 factorial. Let's look at it. All right. So our answer is going to be 10 factorial upon 4 factorial times 2 factorial times 2 factorial. We are going to stop here because if you check the options, you see that option C, which is the correct option, stops at 10 factorial over 4 times 2 times 2 factorial. Okay, so the correct option here is C. Okay, so because this is a multiple choice question, we stop here. But if it is essay, you can actually simplify further. Okay, all right. So my advice is this: if you are solving a multiple choice question, always look at the options, okay, and stop where the option stops. Okay, so don't overtake the options and don't be behind the options. So always work in line with the options provided. All right, let's look at the second example for today. Example 2. In how many ways can the letters of the word election be arranged? Okay, we have option A, option B, option C, and option D. All right, as 7 factorial, 8 factorial, 5 factorial, and 6 factorial, respectively. All right, let's look at the solution. As you can see, elation is a 7-letter word with no letter appearing more than once. Let's confirm that. E-L-A-T-I-O-N. So since no letter appears more than once, what is the answer? 7 factorial. That is the answer. Very, very simple. So the correct option here is what? Option A. Thank you. Let's look at the third example. Example 3. In how many ways can 7 directors sit round a table? Wow, this is an interesting question. Maybe we can practicalize it. Okay. All right, we have seven directors, okay, that want to sit around a table for an important meeting. So you are being asked, in how many ways can this be done? All right, is it 720 ways? Is it 120 ways? Is it 24 ways? Is it 5,040 ways? Okay, we're going to look at the solution. All right. But I want to tell us here that this kind of permutation is called cyclic permutation. It's called what? Cyclic permutation. It's a kind of arrangement in a circular manner, and it has a formula. All right. The formula is n minus 1 factorial. All right. N minus 1 all in bracket, then put your factorial. So this is the formula for cyclic permutation. So anywhere you see this kind of question, okay, that has to do with circular arrangement, or that has to do with circular part, okay, the formula is what? N minus 1 factorial. Please don't forget. You may take down note. You can pause the video and take down notes for yourself. All right. So since we have seven directors, I believe at this point you already know the number of ways they can sit around a table. So the number of ways is what? 7 minus 1 factorial, and that gives us 6 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and that returns 720. So the correct option here is what? Option A. Right? So that is just that. Very, very simple. Okay? All right, let's look at the fourth example for today. In how many ways can 3 seats be occupied if 5 people are willing to sit? Earlier we gave a formula, okay? The formula is n permutation r equals to n factorial all over n minus r all factorial. That formula is used when a part of a whole is being arranged. Okay, now let's look at the solution to this very problem. You recall the formula that we studied earlier. Okay, so our n here is going to be what? 5. Then our r is going to be what? 3. Is that clear? Because there are 3 seats and there are 5 people. It means you are arranging 3 at a time. Okay, out of 5 you are arranging 3 at a time. Okay, so 5 permutation 3 is equal to 5 factorial upon 5 minus 3 factorial, and that gives us 5 factorial over 2 factorial. We cannot stop here because looking at the options, we don't have anything like this, okay, in the options. So we are going to simplify further. All right, so we are going to have 5 times 4 times 3 times 2 factorial, then all over 2 factorial. Okay, we stopped at 2 factorial because we have 2 factorial down, so it will be easier for us to cancel the 2 factorials. Okay, so 3 factorial is actually 3 times 2 factorial. Okay, it is same as 3 times 2 times 1. Okay, let's take it up. 10 factorial is also same as 10 times 9 factorial. As long as you are not stopping at 1, so anywhere you stop, just put factorial there, you still get the same answer. Okay, let's pick 7 for instance. 7 factorial is same as 7 times 6 times 5 times 4 factorial. Or we can remove it from 4. We can still move down to 3 times 3 factorial. Okay, so 5 factorial is same as 5 times 4 times 3 times 2 factorial. So we stop here because there's a 2 factorial down. Okay, so at this point the 2 factorials can cancel out, as we can see. Then what we have left is what? 5 times 4 times 3, and that gives us 60. And the correct option is what? Option C. Very, very simple. Let's look at the fifth example for today. How many three-digit numbers can be formed from 3, 2, 5, 6, 4 without any digit being repeated? Okay, this example 5 is similar to example 4. All right, here we have 1, 2, 3, 4, 5. Let me count again. 1, 2, 3, 4, 5. Okay, so we have 5 numbers, and we are going to arrange 3 digits, okay, without repetition. All right, so this is 5 permutation 3. Is that clear? It's 5 permutation 3. So let's look at the solution. Yes. So we recall our formula as usual. N permutation R is equal to n factorial over n minus r factorial. All right. So our n is 5, then our r is what? 3. And that gives us 60 as we got earlier. All right. It's very, very simple, not hard at all. Okay, let's look at the sixth example for today. Example 6. I like this question. If 6 permutation R is equal to 6, find the value of 6 permutation R plus 1. Wow, interesting. Option A, 15. Option B, 30. Option C, 33. Option D, 35. Let's look at the solution to this question. We recall our formula, okay? N permutation R is equals to n factorial upon n minus r in bracket, then factorial. All right? Now, we are given 6 permutation R equal to 6. This is an equation, and in an equation, we try to solve for the unknown. So in this case, R is an unknown, but we can apply the formula of permutation, okay, to get our R. All right, so we are going to apply this. We're going to express left hand side in a better way, so that we'll have a way of getting a value for R. Once that is gotten, then we'll now come to 6 permutation R plus 1 and substitute for R, then we'll get a value for 6 permutation, whatever R is, plus 1. Okay, let's just move on. So 6 permutation R is 6 factorial all over 6 minus R, all in bracket, factorial. Then we maintain our right hand side. Right? So we are going to further work on the left hand side, okay, so that we can get the value for R. As you can see, we have 6 at the right hand side. So if there is a way we can work on the left hand side to have 6 standing out, okay, so that 6 can cancel out 6, or so that we can divide both sides by 6, it will really help us. Okay, so that's the goal, okay, or the destination. Okay, how we can factor out 6. Of course, if you check the left hand side, you see that 6 is a factor, okay? So if you can factor out 6, okay, then we can actually divide both sides by 6 so that in the right hand side we can have 1. So let's see how we can do that. All right? So we can actually express 6 factorial as 6 times 5 factorial. Nothing has changed. Okay? 6 factorial is same as 6 times 5 factorial. Nothing has changed. Okay? Then we are going to further express the left hand side as 6 into 5 factorial upon 6 minus r factorial. Then we maintain our right hand side. We equate 6. Okay? So nothing has actually changed, but we are trying to express the equation in a more meaningful way. Okay? So at this point, we can divide both sides by 6. Or you can say 6 cancel 6. All right? So we are going to have 1 remaining at the right hand side. Okay? So if we divide both sides by 6, then 6 will cancel 6. All right? Okay? So you can choose to say divide both sides by 6, or you can just say 6 cancel 6. I think they are all the same. All right? So what we have left is what? 5 factorial all over 6 minus r all factorial. Okay? So at this point, we need to cross multiply. Right? When we cross multiply, we'll have 5 factorial equal to 6 minus r all in bracket then factorial. As you can see, we have factorial at the left hand side. We also have factorial at the right hand side. So the 2 factorials can cancel out. Then we are left with 5 is equal to 6 minus r. Okay, we are solving for r, don't forget. So at this point, the value of our r is what? 1. Okay, so we have gotten a value for r. What do we do next? What we are to do next is to substitute for r, okay, so that we can get a value for this whole expression. Okay, all right. So let's get that done. So we're going to have 6 permutation 1 plus 1, right? So we're going to have 6 permutation 2. So what this means is that we are solving for what? 6 permutation 2. Okay? So 6 permutation 2 is 6 factorial all over open bracket 6 minus 2 close bracket then factorial, and this gives us 6 factorial over 4 factorial. Then we'll simplify further and our answer is what? 30 permutations. So the correct answer here is what? 30. All right, let's look at the last example for today. We have example 7 that says 5 people are to be arranged in a row for a group photograph. How many arrangements are there if a married couple in the group insist on sitting next to each other? Wow, an interesting question. All right, of course, it is expected the couple should sit next to each other. Okay, yes, this kind of permutation is called conditional permutation or permutation with condition. Okay, so of course we're still going to apply the formulas that we know already, but there is a kind of reasoning, there's a kind of common sense that we need to bring in so that we'll get a correct answer. Okay, so you have to really consider the attached condition, okay, in your solution. Is that clear? All right, let's look at the solution. Solution. We recall our formula for factorial. Of course, if you are to arrange five people in a row, there are five factorial ways this can be done. All right, but then we are not stopping at five factorial because there is a condition attached. Okay, and the condition says that the married couple want to, sit next to each other anywhere they are. Okay, anywhere they appear in the row, they want to be next to each other, right? So that needs our attention. Now we arrange them this way. Since the couple want to sit next to each other, they can choose any position. Of course, we have one, two, three, four, five. Okay, they can choose to sit anywhere. Okay, but wherever they choose to stay, they will always be together. There won't be anybody that will sit in between them. Okay, so we assume that they chose the first two seats. Okay, so it then means that the first two seats is a collection. Okay, then we now have the second, the third, the fourth. So this means what we have here is what? 4 factorial. Okay, so because the couple are sitting next to each other, so two seats, okay, can be seen as a collection. All right, so we are going to have 4 factorial. Okay, there are 4 factorials. There are 4 factorial ways this can be done. All right, but then within this couple, all right, there are 2 ways they can sit next to each other. Is that clear? The man can choose to sit here while the woman sits here, or the woman sit here, the man sits here. Is that clear? That is, the man can choose to sit on the first seat. When I say the man, I mean the husband. Okay, then the wife can sit on the second seat, or the wife can sit on the first seat while the husband sits on the second seat. So there are 2 factorial ways, okay, the couple can sit next to each other. Is that clear? So this brings our permutations to what? 4 factorial times 2 factorial. The first arrangement is 4 factorial, okay? Because the couple are sitting next to each other. So 2 seats are regarded as a collection, as one thing, okay? So that gave us 4 factorial. Then there are 2 factorial ways the couple can sit next to each other. So the total permutation here is 4 factorial times 2 factorial, which gives us 48. Okay, so that is the answer to this question. Whenever this kind of question comes your way, just take your time and apply common sense, as I said earlier. Okay, so apply common sense and you will get it. All right, you will get it. The formula is not going to change. Okay, but beyond the formula, you need a kind of, you need a level of reasoning. You need to think through. Okay, so that's why I like this topic. Beyond the formula, you need to think. All right, so it's an interesting topic. So this is all I have for you today. It's actually a lengthy video. Yes, the lesson is for those preparing for JAM. It's for further maths students. So that is why we have to make it a bit lengthy for proper understanding. All right. I have some questions for you to practice. It's in my habit to give questions for my listeners to practice. So these questions will help you to really help you to know if you really understood what you have watched. Okay, let's look at the first one. I normally call it check yourself. Okay? Check yourself. Check yourself. Number one, you can read. Number two, this is it. So try to solve these questions and drop your answers in the comment section. All right? Don't forget, try to solve them. They are not difficult, okay? So try to solve them. Then I have the next one. I think there are four questions, as you can see here. There are four questions. So solve these four questions and drop your answers in the comment section. All right? Yeah, I know you have learned a lot, and these four check yourself questions will not be difficult. All right? In case you are not able to solve any of them, please let me know in the comment section also, so that I can profile solution. All right? Thank you so much for your time. Do well to subscribe if you have not done so. Thank you. Let's meet in the next lesson. Bye.